Hi there. Thank you for clicking on this video. This is our practice set for solving quadratics by square roots. Please like and subscribe for more math content, drop a comment or question below, and check out the other videos and playlists on the channel, see what else we can help you out with. As always, pause the video to work these problems on your own and then come back to check your work. Right, so for these first five, hopefully you did not do more work than the directions asked you to do. These are yes, no questions, as in, yes, I can use square roots to solve this equation, or no, I cannot use square roots to solve this. And that's actually a really critical skill, is knowing when you can use it and when you can't. So remember that to use the square root method, the b value in your quadratic has to be 0, which essentially means that the b value isn't there. So you can have something with an x squared, and you can have as many constants as you would like. You can actually have more than one x squared if you wanted to. You just combine them together. But you can't have something multiplying an x. So there cannot be an x term, or what we call a linear term. So in this first one, because there's a 2x there, the answer is no. This strategy will not work. And if you did launch into trying to solve it, you'll notice that you run into some problems pretty fast, because you end up with x's on both sides of the equation and no way to combine them or get rid of them. So the second one has an x squared and a constant, no x term, so that's fine. Third one has an x squared. Now this one's got like 2 constants to it, but you could just, you could technically subtract the 6 from both sides. So 5 minus 6 is -1, and now you've got it in the right form. Now that is doing some extra work. I wouldn't do that step. I would subtract 5 from both sides, but you don't have to do anything for this particular one. So we're just going to simply answer, yes, I can use square roots. This next one has the c on the other side. It's not really c, I guess it would be -c in this case, but again, not what we really care about here. I see an x squared, I see a constant. As long as I don't see an x term, then the answer is yes, I can use this strategy. And then for number 5, we're just gonna home in right there on that 3x. The moment you see that 3x, the answer is no. Now, it doesn't mean that the problem isn't solvable. In fact, it is solvable. It's possible to solve all of them given the right strategies. You just can't solve it using this strategy, because we need to do some other things to deal with having an x in there. So first 5 were just yes and no. If you did try to do them all out, please remind yourself to read directions. Okay, so the rest of these we are doing out. And so I mentioned earlier, like on the last slide there, that if you want to get it in the right form, you can do something like this, where you subtract 57 from both sides and figure out what that value is. And there might be times when you need to do that, because you need to get that value. However, if you're just solving it, you're going to move everything to that right hand side anyway. So I'm just going to subtract the 3 from both sides, and that's going to get me 3x squared is equal to 54. Now this is multiplication, and we can undo multiplication with division. 3 divided by 3 is 1. And then what is that? I think that's 18. 24, yep. Okay, and now we will take the square root of both sides, but remember, it is a plus or minus going on that right hand side there, because there will be 2 values that will make it true. Now, if you stopped there, you did not simplify as much as possible. So we can simplify that. We're going to look for perfect square factors. So 18, I'll do a little scratch work right here, can factor into 9 times 2, and 9 factors into 3 times 3. So 3 times 3 times 2, and there's my perfect square. So I've got a 3 squared right there. The square root of 3 squared is 3, so the 3 comes out, and the 2 is still inside. And so the simplified answer to that is plus or minus 3 root 2. Next one, we'll start it off a similar way. So we'll subtract 2 from both sides. So I have 1/2 x squared. 2 minus 2 is 0. And 10 minus 2 is 8. Now, you could do this. All right, this is 100% okay. You can go grab your graphing calculator, or not a graphing, any calculator will do. But you can grab your calculator, just do 8 divided by 1/2 would get you there. Most people don't like that notation. And so what we're going to do is remember that we can undo that 1/2 by multiplying it by 2/1. So what that does on the left, 2 times 1 is 2, 1 times 2 is 2, and so you end up with 2/2, okay? And this is 8 times 2 is 16, and 2/2 is just 1, okay? So I did an extra line out there. Like normally I would just say like 1/2 times 2 or 2/2 is 1, and I wouldn't bother to write it, but just so you can see what's happening there. It's not magic, it's not voodoo, just 2/2 is 1. And now let's go ahead and take the square root, and remember that you are having to plus or minus it there. My square root symbol kind of went over the 1. We don't want to do that. There we go. Square root of x squared is x, and then the square root of 16 is 4. And so that would be plus or minus 4. Next one. All right, so same deal. I am not going to play around with, moving stuff into a particular form. I know I want to get the x by itself. -4 plus 4 is 0, so I end up with x squared is equal to 0. And then we'll undo the x squaring by taking the square root, and the square root of 0 is 0. There is no need to write plus or minus 0 on that, because that would be the same number. But 0 is not positive or negative, so you just don't write that. Okay, but it's redundant. I don't know if it's wrong necessarily if somebody wants to write plus or minus 0, but it is not necessary. All right, next one, got decimal in there. That might be fun. All right, so let's go ahead and start this one by subtracting 5 from both sides. And 6 minus 5 is 1. And if you've got a calculator, if you are allowed to use a calculator, you might as well just like dump that in there. So we divide by 0.4, and so we have 1 divided by 0.4. I was lazy. I was like, I didn't have a calculator. So what I did was this is 1 divided by 0.4. And then I just think of it as this is 1 divided by 4/10. Because that's what that is, which would be 1 times 10/4, which is just 10/4, and that simplifies to 5/2. And so we end up with 5/2 there. And that's x squared. And then we would square root that. And so we get x is equal to plus or minus the square root of 5/2. Now, what we have not talked about on this channel at this point is something called rationalizing a denominator. So that would be a good place to stop. Okay, to stop the problem, plus or minus the square root of 5/2. Or if you wanted to, without me going through the process of rationalizing the denominator, I'll show you one other way you could kind of get around it here. Instead of doing that simplification step, I'm going to write this, plus or minus the square root of 10/4, which would be plus or minus the square root of 10 over the square root of 4. And you actually can take the square root of 4. The square root of 4 is 2. So this is the more correct answer, but does kind of get into one of these weird formalities of math that I just don't want to get into too much. All right, last one. We're going to go ahead and subtract 8 from both sides. So 4x squared equals -8. And then we'll divide both sides by 4 to get x squared is equal to -2. And now we run into the fact that there is nothing that will square and give me a negative. And so the way I mentioned in the video lesson that you want to answer that is no real solutions or no real answers. because there's nothing you can plug in that would give you a 2. And a lot of people are like, oh, it'll be negative the square root of 2. No. Like as soon as you multiply something by itself, it's not negative anymore. Okay, so no real solutions on that one. All right, so that was all of the problems in this particular practice set. Hopefully you found that helpful. Please like and subscribe if you did. Drop a comment, ask a question below. There's a lot of weird ideas that are introduced here, like, what do you mean real numbers? Or what is this rationalizing the denominator? Like, I don't even like that word. Drop a question, ask me something about it. If your teacher does not want your answers in this form, and we'll see what else we can do. Check out our other videos. I'll link some videos playlists to the screen in front of you, and I will see you in the next one.